There are a couple of excellent tools on the internet for beam analysis. One of them is Beam Guru. So I'm going to go into Google and I'm going to type Beam Guru here, hit enter, and I'm going to go to the beamguru.com site. And what we're going to do is we're going to use this tool to calculate and develop the example problem we did before, and then you're going to go ahead and use it to calculate and develop problems 1 and 2 using Beam Guru. You're then going to go ahead and print it and submit, and then you can compare what Beam Guru came up with your own calculations that you did in AutoCAD and submit it for problems 1 and 2. So let's start with the example problem, and then after we finish with that, we'll compare it to what we did in the example problem, and then you can go ahead and start problems 1 and 2. So we're going to go ahead and we're going to start calculations. And the first thing that we've got to do is we've got to make sure and we've got to set this up correctly. So I'm going to go ahead and I'm going to delete everything. It looks like it's already set up for it the way that we had before, because I had done it as an example. But what we're going to do is we're going to go ahead and set this up correctly. Let's go ahead and delete that for now, and delete both of these. So we start basically with a fresh screen onto here. So we have nothing in here placed right now. So you can think of this basically as either our beam diagram or as our free body diagram that we're going to develop. So the first thing we're going to do is check our units of measurements. We are in foot, and our units of force are pounds force. So we are in the correct unit formats for this for both four. First thing we're going to do is establish the length of our beam. I'm going to go ahead and type 20. These units are in feet, so all I have to do is type 20 feet in there. The next thing I'm going to do is I'm going to go ahead and apply the two supports on either side. If you recall the example problem, we had a pin support on the left-hand side, and then on the, so that we're going to go ahead and add, and then what we had is a roller support, and that was going to be on the right-hand side, so we're going to go ahead and add that. So let's check what we've got in here. There's our pin support right in here, and as you notice, it's got two vectors, both a vertical vector and a horizontal force vector onto there, while the roller connection here on the right only has the vertical force vector located, again because there is no, it allows for motion horizontally, so there will be no reaction force horizontally on that. Let's go ahead and let's add our loads onto here. So the first thing we're going to do is do our point load. So our location, and it starts from the left, is going to be at 6 feet, and the magnitude of that one was at 4,000 pounds. We're going to have it as a load coming down onto that, and we're going to go ahead and add that. It's acting at 90 degrees to the beam located right in here. There's our 6 feet and our 14 feet. The next thing we're going to do is add our distributed load, which was at 650 pounds per linear foot throughout the entire length of the beam. So let's go ahead and go to our uniformly distributed load onto here, and the start location is going to be at 0 starting from the left, and the end location is going to be at 20 feet, and then the load magnitude was at 650 feet. Again, it's a downward load coming down in that direction, and there it is. We're going to go ahead and add that load. So right now what we've basically done is we've done the same thing. We've set up the beam and we've set up our diagram the way that that initial beam we did in the example problem was loaded. Take a look at it. There's our concentrated load, there's our distributed load onto there. There are two supports located in there. And it's almost as simple as that. What we can do is now try to solve for the problem. Make sure these are clicked to calculate the reactions at the sort of the beam, at the supports of the beam, and calculate bending moment diagram and the shear force diagram. We don't need the actual force diagrams or invert the diagrams of moment at this point. We're good. We're going to show the moment as positive in this condition. So we're going to go ahead and solve. We're going to click solve right in here. And then if you scroll down, you take a look at it right in here, and you can see our shear moment diagram and our bending moment diagram, which look almost identical to what we had. The only difference is that their vertical scale here has been foreshortened a little bit more than ours, but the values match up perfectly to what we have. There's our point of zero shear. There's our negative 7,700, our positive 9,300 force right here. That would be our Vmax, our maximum shear. And of course, our maximum moment will occur where we have our zero shear point right in here at 45,607.69. Now this should be almost identical to what we had, with the exception of some rounding, which that would be okay. The shapes look identical. This is that kink that I was talking about in the other video onto there. This may not look exactly as the way we drew it, but the intent is identical to that. If you continue to scroll down, you can see that you've got your calculations for the reactions at the supports in here. They're using all the equilibrium equations that we used. Forces, sum of all forces and sum of all moments equal to 0 onto this. Here's our calculation for RB, which is our vector located here. That is our support on the right hand side, is 7,700 pounds. And then we solve for RA right at this point, and that is going to be 9,300 is the support reaction on the other point. And with that, we basically have the correct thing. Here we go, and we've got our maximum moment also located right in here, which is 45607.69 pounds per foot. So once we've got all of this, we can actually go back and we can right click at this point. Let's go ahead and print. We're going to save as PDF. You should be in portrait 8.5 by 11. Let's go ahead and let's scroll down. And what we've got is we've got all the settings here and the support settings located in here. Keep going down. You should have your diagrams in here, and then you can continue through with your calculations down at the end. So what we're going to do is we're going to go ahead and save as PDF. I'm going to go ahead and save to my desktop at this point. You can call it whatever you want. In our case, in your case, it'll be problem 1 PDF. Problem 1, what we would call beam calculator online, bending moment and shear force. You can call it whatever you want as long as it's well identified. We're going to go ahead and save onto that, and we are done. The only thing you may want to do is to go ahead and let's go to our desktop, and you can take a look at for your file in there as a PDF. Let's go ahead and take a look and see if we've got our beam calculator online. This is what they ended up calling it at this point. I'm going to go ahead and double click on it, and this is what you should be submitting for the 2 problems. And that should be it. Please submit those as PDF formats for the second part of this assignment. Thank you.